981, the numbers 36, 64, 4, 16, 100, 144, 121, and 225 are all examples of perfect squares. Part A. If each of these numbers represents the number of square units in a square, what is the side length of each square? Well, we know that all squares have 4 sides, and all of those sides are equal. So if we have these perfect squares, and we know that these perfect squares represent the number of square units in each square, then we need to figure out, okay, so what number times what, or what number times itself, I guess, would give us 36. Well, without having to do any complex calculations or using my calculator, I know that 6 times 6 gives me 36. So my side lengths are going to be 6. My next perfect square is 64. Again, I know that 8 times 8 gives me 64. So my perfect square is going to be 8. Or I'm sorry, my side length is going to be 8 for that perfect square of 64. The next is 4, and I know that 2 times 2 gives me 4. So perfect square of 4 would have side lengths of 2. 2 times 2 gives us 4. A perfect square of 16, again, I'm not doing any complicated math here. I know that 4 times 4 gives me 16, so my side lengths are 4. Moving on to my next perfect square of 100. Again, I know that 10 times 10 gives me 100, so the side lengths of this square would be 10. All right, moving on to 144. Again, now for me, this one is not complicated because I know that 12 times 12 is 144. If we're getting into tricky territory for some of you, then, you could guess, well, I know 10 times 10 is 100. Then you could maybe try, well, 11 times 11, what does that give me? Well, it's going to be too low. So then move on and try 12 times 12. What does that give me? Oh, well, it gives me 144. And that's only if you don't know that 12 times 12 is 144, but it might be tricky for some of you. All right, the next one is a perfect square of 121. Well, I know that 10 times 10 give me 100, and 12 times 12 give me 144. I'm going to try 11 for this, so 11 times 11. And when I do 11 times 11, I do get 121. Now, you are welcome to use a calculator for this. Again, I tried 10 times 10 first. I know it's 100, so it has to be a greater side length than 10. But it also has to be a greater side length than 12 because it's only 121. So if you need that calculator to do 11 times 11, definitely do it. If that's great if you want to use your brain, but check it with a calculator to be sure. All right, the last one is 225. Okay, so I don't know off the top of my head what times what gives me 225. I do know that 13 squared gives me 169, so I know it's got to be larger than 13. All right, so what is 14 squared, or 14 times 14? Put it into your calculator and see what you get. So 14 squared, it gives me 196, so we're getting closer, but it's got to be larger than 225. Let's try 15. All right, 15 squared. When I put it into the calculator, I get 225. So our side lengths for this perfect square are going to be 15. All right, and that is all we have to do for part A. Now for part B, why do you think these numbers are called perfect squares? Well, think about it. So when we have these side lengths. We are multiplying the side length, to find the area or the perfect square, we would do 6 times 6. Or another way of saying that is 6 squared. So basically, the reason that this column here, these are perfect squares because each number of square tiles can be formed into a square with whole number side lengths. So notice how each of our side lengths, they weren't decimals and they weren't fractions. They're nice whole numbers to work with. So that's what we're going to explain for part B. So again, make sure what I'm writing, you are writing as well, because you do need to show your work. So we are going to say they are perfect squares. So they are perfect squares because each number of square tiles can be formed into a square with whole number side lengths. Now suppose we have an area, or let's suppose we have an area where when we try to figure out what number times itself gives us that area, it gives us a decimal or a fraction. Well, then its area is not a perfect square, because the key here is that these, again, this list in this column, these are perfect squares because you'll see that each of the side lengths are a nice whole number. All right, and that is the end of 981.